if you want to achieve a little extra credit, okay? And that is if you do a free body diagram of the output shaft of your system, okay, and from that, determine what the radial, maximum radial load into the wall bearings, what that maximum radial load is into the wall bearings, and then compare that maximum load to the load rating for the bearing itself. In other words, is the bearing comes from McMaster Carr. So you go to the McMaster Carr site, you pull up the data sheet, you take a look at what the load rating is, and you compare it to the maximum load that you calculated. Okay, so that's a fifth item that you can do in terms of additional calculations that that you can gain extra credit for. Any questions on these last two sections, the design load on the motor and the additional calculations? Raise your hand if you have a question. Oh, you guys are making it easy today. All right, so the final part of your design report will be the stress calculation on your gear teeth. All right, and in class, I provided an equation for determining the tooth stress. There's a couple different ways you can determine tooth stress. Professor McGinnis used a slightly different method than the one that I taught in class. You can use my method, and I can give you her method if you're interested. But if you want to gain some additional extra credit, you can go ahead and use the formula that I provided in class to determine the tooth stress, and then determine what the factor of safety is, assuming that Lexan, which is a polycarbonate material, has an ultimate strength of 4,500 psi. Okay. And if you go ahead and do a stress analysis as part of Inventor on the output gear tooth, that will also be viewed for extra credit as well. So that is an additional option, which I will put into the notes here. That additional calculation will be confirmation of calculated tooth stress compared to stress developed in Inventor. Okay. All right. So those are the calculations that you'll need to provide as part of your project report. Are there any questions on any of these items that I've presented and that I've walked through? Okay. Raise your hand if you have a question. Now's the time to ask. Okay, Patrick. Let me see here. Okay, I've enabled audio, Patrick, or you can use the chat box, is fine. Yes. So basically, the calculations that you provide in your report, okay, should follow the same style and derivation that you provided in your technical analysis memo. Okay, so let's talk. That's an excellent question, Patrick.
Auto shutdown initiated.
So that I can talk a
Auto
little bit
shutdown
about
canceled.
the style
Mic off. Mic on.
of doing calculation derivations in technical memos. One of the things you're going to have in your report, a lot of calculations, okay? And so one of the things you should get used to is numbering the equations, okay? And typically the way that the equations are numbered is that let's say that you have an equation. Let's say here, let's say equation is P max equals T stall divided by 2. And I don't have the ability to do subscripts and all that stuff in the notes section, but I'm just trying to give you an example. Um, Times omega no load divided by 2. Okay, over here, not in the right-hand margin, but just inside the right-hand margin, you want to put the following. Okay, your first equation noted as equation 1. Okay, then as you go through each derivation, the next one is equation 2, equation 3, equation 4. That way, when you're talking about substituting values in the previous equation, you can refer to the equation number. Okay. So Patrick, does that answer your question? Okay. Any other questions? Okay. All right. So one additional thing I want to make you aware of is that Professor McGinnis and I went through and we graded the mechanical design part of your team project. And so those grades have been posted on Brightspace. Um, and when we get into the control system grade, that will include your scores on your Arduino exercises, plus also your code, okay? And I'll be talking a little bit about your code here in a few minutes, talking a little bit about how you go through the process of setting up your code generation. Okay, so I'm going to go ahead and I'm going to bring in, okay. All right, so before we get into flow charting a little bit, um, and I'm going to try to use this class to get you jump started on coding the up function within your project. Okay. Um, so what I thought I'd do is I just put together 2 or 3 view graphs just to summarize the functions, the variables, and the control flow uh, structures that you can use within Arduino. Okay. So for the digital functions, you see them here. You use the pin mode, which is a 2-parameter function with the pin number, and if it's an input or an output. Use digital read, which is simply you're reading the state of a digital signal at a certain pin, and then your digital write, you're writing a certain value, whether it be low or a high value, to a designated pin. Okay. Now, one thing I want to make you aware of, and as we're getting into the coding part of your project, um, let me see if I can find it here. Okay. Uh, the document that's going to be posted here in Share Windows 7, okay? Uh, these are the pin numbers that we would like for you to use in your code, okay? And the reason is we want you to use specific pin numbers is that your code will be evaluated on a test setup, and that setup will be utilizing these pins, okay? All right, so this document is also up on the Elevator Team Project section of Brightspace, along with the Week 13 content section, okay? So these are the pin numbers that you should be using, okay? On Thursday, I will identify the variable names that you should be using as well. And the reason we want to use common variable names across all the teams, it's just a lot easier for Professor McGinnis and I to review code and to assess code, especially if you're having issues where it's not running quite right. If you all use the same pin numbers and the same variable names, it makes it a little bit easier for us to assess your code. Okay. Any questions relative to the PIN numbers that you use in your code and the digital functions? You should be well versed with the digital functions from exercises 1 and 2. Any questions? Raise your hand if you do, if you have any questions. Okay, so like I said, this PDF file is up on Brightspace, so you can access it. Um, the slides shown here are up in the week 13 folder as a PDF file. Okay, so in addition to the digital functions, there are control flow elements within Arduino that you will want to consider using in your code. There's the if statement, which is based on a certain condition in terms of whether or not the content within the brackets is executed or not. There's a for structure where you increment an integer value if you want to execute something for a certain number of a predefined number of iterations. And then there's the while structure. While there's a certain condition, you execute what's within the brackets following that control element. So the if, the for, and the while are three control flow elements that you'll want to consider using. I will give you a little bit of a piece of advice. I would lean towards using the while control flow element within your code. I think it will be easier for you to use that element, that control flow element, in developing your code. So keep that in mind. Um, the if and the for, there might be one part of your code that you could use it. I don't know if it's that elegant. I think the primary control flow element you'll want to use is the while element. So just keep that in mind. Any questions on control flow elements? Okay. Yep. Feel free to raise your hand if you have any questions. Okay. And variables, as I mentioned on Thursday, providing, just like I provided the PIN number definitions, I'll be providing the variable names. Okay. Um, and just a couple things. Remember local versus global in terms of where the variables are specified. Um, Remember that you don't want to over-specify your variable. In other words, is that if you're talking about a variable that's going to have a value between 0 and 255, basically an 8-bit representation, don't specify it as a long variable, okay? Because that simply that designation just uses more memory within your system than is needed. So it's a way to make sure that your code is structured efficiently in terms of utilizing memory resources on your board. All right, so keep that in mind. Um, so that's just relative to variables. I just wanted to kind of just rehash that quickly. Um, and the thing is that the way that you should look at it is, definition of global variables up top in your code. You get into the initialization of the variables within the setup part, and then you get into the changing variable values within the loop element or the loop structure of your code. The other thing that I will also well, I'm going to hold off recommending one other thing until I get a little bit into the flow charting part of getting your code set. Um, so in terms of, you know, one of the common ways that uh, software architectures are illustrated is using flowcharts. Okay, and so the symbols that you see here are primarily the symbols that you'll be using in your flowchart. um, for setting up your code development. Okay. Um, One of the assignments for Thursday will be for each of you to make a first attempt at flowcharting your up function for your project. Okay, and I'll kind of work through how you can set up the flow charting and then the function definition and then the variable definition to sort of help you translate from the flow chart into your code. All right, but these are what you see here on the right hand side are the primary elements that you're going to use. Okay. Um, a rectangle is simply a predefined process. A trapezoid is an input-output element. So in other words, is that when you're reading a button state or you're writing a value to an output, that is when, that function, you'll represent that in a trapezoid. A diamond represents a decision element. In other words, is you make you make a or you state a question: is such and such this state? And then typically you have a yes branch which goes off, and then a no branch to identify the flow based on the answers to the question that's posed within the diamond element. The circle is just a connector element. It's typically used for loop back representation. Um, the rectangle with inside borders is a predefined process. That's a subroutine. Okay. Now, um, one of the things that I will recommend to you that you consider is that you will have an acceleration phase of lifting your elevator. And you will have a deceleration phase of lifting your elevator. And then you'll also have a phase of lowering your elevator. Okay. I would recommend that you consider subroutines for each one of those functions. That way, it's your code will be not as cluttered, it'll be more organized, and if you need to make a change, it'll be easier to identify where the change is that needs to be made. Okay, so you'll have your constant definitions, your global variable definitions. You'll have your setup part of your code. You'll have your loop part of your code, and then you'll have some subroutines, okay, which you will call from your loop part of your code, okay. So my recommendation is that you consider having subroutines, and they're very, very, very short subroutines, but it's good to break things out uh, for for operations that you do consistently within a system. Instead of just rewriting the code time and time again within the loop portion of your code, you have a constant subroutine that just gets called from the loop part of your code and gets executed. And it's just a better way to maintain an organized set of code. Um, and then the rounded box, or some people call it the oval, is a terminal element, and it's just basically a start or an end of your system operation. And then flow lines are obvious, and you'll see that. I'm going to show you an example here quickly. So, are there any questions on flowchart symbols? Raise your hand if you have a question. Okay. Okay. So back, I think the last class or the class before, I can't remember, to be honest with you. I showed you the the top level flow for the elevator system that Professor McGinnis had put together. Okay. Um, I decided that I was going to expand that high level flow. Um, Now, you may look at the expanded high level flow and say, do I have to code all of that? No, you don't. okay? Because I'm going to specify a couple conditions, which is going to simplify your code significantly. But the reason I went through and expanded the flow chart, okay, was to show you that how the input-output elements in your flowchart, how they are used along with the subroutine portions of your code, okay? So if we just quickly walk through this, all right, you'll obviously have the start of your code operation when your Arduino has its code loaded and it's powered up. You'll set your defaults, you'll initialize your variables within the setup portion of your code, and then you'll go into your loop function, okay? And if you wanted to have a system which didn't know where the elevator cab was, and so you had to be able to work your system, whether it was on the lower floor or the upper floor, then this type of control flow would allow you to do that. Okay, but again, your code's not gonna have to do that because one of the things that you can assume is that your elevator cab system, the elevator cab will be at the bottom floor at the start of your process. Okay, so what does that mean? Well, it means that the way that you will code the system will be similar to the very simplified representation on the left-hand side here. Okay, and basically you'll just loop through and keep monitoring the up button until the up button is pressed, and then you'll go in and you'll execute your up routine, your up subroutine. Okay, but okay. But in the real world, okay, the systems, they're not going to tell you that an elevator cab. You can assume it's going to be at the bottom floor every time you start out, because that's not the way things are usually set up. And so you have to be able to identify where your cab is to determine if the function that you've input into the system, if you want to try to process that function. Okay, so just taking a look quickly. And again, I'm just walking through this to give you an idea of the flow. Okay, you don't have to code this complexity into your Arduino code for the project. All right. So basically, if you had to determine where the cab was, you would read the cab position, and then you would monitor the up button. Okay. And if the up button was pressed, you'd then make a determination, is the cab at the bottom floor. If it was, you'd execute and then reloop. If it wasn't, you'd error message and then go to read the down button. Okay? Because if it's not at the bottom floor, it's at the upper floor. And the chances are the button that's going to be pushed that you're going to want to process is the down button. Okay? But even in that, in pressing the down button, you'd ask yourself the question, okay, is the button pressed? Yes, it is. Well, is the cab at the top floor? Because that's the only function that will change the state of my cab is pressing it to go down. If I press the up button and it's at the top floor, my code's not going to be able to drive it because my system, there's no place for it to go. So again, if the cab was at the top floor, you press the down button, you'd say, okay, go ahead and execute the down function and then get back into the loop. Okay, if it wasn't, you get an error message and then you go back to the start of the loop and start the process all over again. All right, so that's an expanded high level flow. Okay, the other reason I show you that is because there are some times when you're going to want to put the read functions and the decision making part of your flow at the top level and then simply write the individual subroutines which get executed if certain conditions are met. Okay, so that's why I wanted to show you this expanded high-level flow. All right. Again, you don't have to, your code does not have to be this complex because the assumption is when your system starts, the cab will be at the bottom floor. Okay. So this is just an example to show you how typically decision making is done in the high level part of your flow chart, in the high level part of your code. Any questions on this? And again, I'll say it again, you don't have to code in this complexity, okay? Your code is going to represent more of the flow on the left-hand side, the very simplified high-level flow, okay? Everybody on board, give me an agree if everybody's on board with that. Raise your hand if you have a question. All right, good. Okay, so what I thought I'd do now is go a little crazy and see if I can share my desktop. Okay, share my screen. Okay, let's go wild and crazy here. Okay, all right. So I assume everyone can see the three-column document at appdiagrams.net. Uh, Raise your hand if you can't for any reason. Okay. All right. So let's talk a little bit about coding your up function. Okay. So one of the things that you know that your cab is going to start at the bottom floor. So one of the things that you're going to want to do, and let me go ahead and just for the purpose of, let me just go ahead and put a start. I'll just put a start element right in here. Okay. All right. So the top level part of your code is determined. Okay. Yep. Cabs at the bottom floor. And you want to monitor for when the up button is pushed. Okay. So the up button is going to be an input. Okay. So you'll want to use an IO element, which is a trapezoid. Okay. So you'll bring your trapezoid into your flow chart, and you'll say read up button. Okay. And we'll go ahead. All right. So one of the functions that you'll use uh, as part of your code, obviously, um, will be the digital read. Okay. Okay. So the reason I show you this format is that this is a way that I have flowcharted just high level code function and determine the specific software and the program functions that are available and the specific variables that I want to use. Okay, so what I will do is right here. So I will develop the flowchart on the left-hand side, and then as I do that, I will determine what functions I will want to use in my code to execute those parts of the flow. Okay. Now, um, let me just kind of see if I can get back. Okay. Okay. So so what you want to do is you want to outline your flow in a left-hand column. Okay. And then in the middle, you'll want to define the Arduino functions that you'll use in each element of that flow chart. And then on the right-hand side, you'll want to define the variables that are going to be used. Okay. All right. So let me give you an example. Let's. I am going to go back and I'm going to share my screen. Okay. So when you get into the start of your loop portion of your code, and sorry, into your up routine, okay? Um, one of the things one of the things you can do, and you can either do it as part of the up routine or you can do it at the top of your loop segment of your code, okay? Is you guys are going to want to use uh, your the LCD liquid crystal display to uh, to produce messages to determine where the cab is and what button you should push. Okay. Now, one of the things that you'll have to do, and I apologize for jumping back and forth, but I feel like I have to do this because I don't want to lose that. Okay. So one of the things that you can do, all right, is in Arduino, you obviously need to provide access to certain libraries. You need to provide access to libraries, and you'll need to provide access to the library for the LCD display. Okay, so in Arduino, at the top of your code, above above your setup section, okay, you will. Oh, is there a question? Okay, you will want to use the hashtag include function, okay, and then specify the particular library that you need to have access to as part of your code. All right. Um, you will need access to the LCD display library. Okay. Um, and one of the things that you'll want the LCD display to do is when you get into the top portion of your loop segment of your code, you'll want to produce a message that says, and let me just go ahead and say, at top of loop code, want LCD to display um, something like a ready message, okay, to to let you know that the system is now waiting for input via the up button. Okay. Um, and so after this ready message, okay, you'll then want to also produce a message on the LCD display to say something to the effect that um, bottom floor and then press up. Okay. So at the top part of your loop, you'll want to drive the LCD display to produce a message that initially says, "Hey, I'm ready," and then it will specify where the cab is and what button to push. Okay. All right. So once that happens and the system identifies that the up button has been pushed, you will then begin to use the servo commands to implement speed control of your drive system. Okay. All right. We'll talk about that probably a little bit more on Thursday, but similar to the LCD displaying ready and then say bottom floor, press up when the cab is on the bottom floor. When the cab gets to the top floor, you want LCD to display top floor, press down. All right. So you want the LCD to produce a message to identify, to let you know where the cab is and what function you can press. All right. All right. Any questions relative to the LCD? Um, what I would suggest you do is read through the Mega 2650 documentation, go to Arduino, take a look at the LCD display functions, and begin to familiarize yourself with the commands that are used in order to print out messages on the LCD display. Okay. Um, so that is one of the functions that your code should produce. Your code should drive the LCD display to identify A, that it's ready, B, what floor it's at, and C, what button you should push. Okay? All right. Questions relative to the LCD display? Okay. All right. So let's talk about what we've gone through. We've talked a little bit about the top level flow chart. The cab is going to start at the bottom floor, um, developing a subroutine for your acceleration, your deceleration, and your lowering of the cab. Now, question. Um, there will be a certain pulse width modulation value that you increase incrementally during your acceleration phase, and you will incrementally decrease through your deceleration phase. Now, when you go to lower your cab, do you anticipate that the PWM level is going to be lower than your acceleration start, or it's going to be higher? Someone want to take a chance at answering that question? Where will your PWM level be when you're lowering the cab as compared to when you're raising the cab? Anybody want to give it a shot? Okay. All right. So let's talk a little bit about driving your system. Okay. Um, and okay. So again, I recommend acceleration, deceleration, and I'll call it descend subroutines. Okay. And the way that you modulate the PWM level is going to be different for each one of these. All right. All right. All right. So in your code, okay, there will be what I will call, this may not be the exact variable name that we will end up using, but I just want to give you an idea. there will be a PWM max value, okay, which will be the highest speed that will run, that will allow the system to be run at. And then there will be a PW min, something like a PW min. And then there'll be an intermediate value, which is like a cruise speed value. All right, and you can call it any. I forget what the variable name was in the previous code, but again, I'll specify that on Thursday. Okay. Um, so what you'll want to do during your acceleration phase is start at a intermediate level and ramp up to your PWM max. Okay. That will be your acceleration phase. Your deceleration phase is where you come from that PWM max incrementally lower back down to that intermediate PWM level. Okay, that will be the decel part of your phase. Okay, then when you go to descend or lower the cab, your PWM level, does anyone want to take a chance? Is it going to be lower or is it going to be higher than, say, the PWM min value? Tyler's going to take a shot at it. I bet you Tyler gets it right. Oh, Tyler. Tyler, I had so much confidence in you. Uh, Typically, you're going to want to drive the system slower because gravity will be working against you. All right. So your level will be lower. Okay. All right. So you meant lower. Yeah. And what you'll do is you'll specify that as a constant, and you'll simply call that constant value in the descend part of your operation, of your subroutine. Okay. All right. So we've gone through quite a bit. Um, so for Thursday, I'll go ahead and I'll create a Word doc with these notes, and I'll post that up at the week 13 folder as well. Okay. So for Thursday, okay, you want to go through and view the videos in the playlist for the Arduino analog input and output playlist. Okay, I believe there's probably 8 or 9 videos, and then there'll be 2 exercises that you'll need to do and submit those via Brightspace. Okay, and in addition to that, I'd like each one of you to begin to think about your up function, okay, and beginning to do the flow chart to represent what's going to happen in your up function, okay. So um, up function, all right. You will want to drive the LCD display when you initially get into your loop phase to tell you that the the uh, the system is ready. And then you'll want it to identify the cab is at the bottom floor and then press the up button. Okay. You'll then want to read the up button. Okay. And then once that up button is pressed, you'll want to go into the Excel phase via subroutine of your operation. Okay. So using the flowchart symbols that I showed you and kind of keeping in mind the high level flow chart, I'd like each one of you to begin to just draw out a preliminary flow chart to talk about the processes that in the reading and the output that's going to be necessary to execute your up function. Again, your up function will consist of an initial ready bottom floor, press up. It will then have uh, an acceleration phase. It will then have a deceleration phase, and then it will arrive at the top floor. And when it gets to the top floor, your LCD will want to say top floor, upper floor, press down. All right. So you'll not only have uh, driving the motor controller, but you'll also have the LCD display that you'll want to drive. I believe that as well. Professor McGinnis also wants to have an LED lit to indicate when the cab is in motion uh, upward and when the cab is in motion when it's being lowered. And I believe when we define the variable names on Thursday, that I'll talk a little bit more about that. Um, so any questions on what is due for Thursday? Raise your hand if you have a question. Okay, just just to review, okay, your up function, right? Your up function is your system's ready, bottom floor, press up, read the up button, wait for the signal that the up button is pushed, get into the uh, speed, the acceleration phase. When you get to a certain position, get into the decel phase, and then have an indication that you've arrived at the top floor and that you need to press down if you want to move the cab. So that is sort of the range of what will need to happen within your up function. All right. So if you take a first shot at just doing a high level flow chart for that, then I can provide you a little bit more detail on Thursday that each team can then go off, take a look at each one's flow charts, and with the information I gave you on Thursday, go through and do the draft flow charting and draft code for your up function. Okay, so that's that's sort of the schedule that we're going to try to keep to allow to have you guys come up with some draft code for your up function by next Monday. Any questions?
Auto shutdown
If everybody
initiated.
understands what's
Auto
due for
shutdown
Thursday,
canceled.
give me an
Mic
agree.
off. Mic on.
Okay. If you have any questions relative to the homework, send me an email. If you have a flow chart that you'd like me to look at, just send me an email. Let me know when you're available. I can set up an Adobe Connect session, and we can walk through your flow. Okay, but do the Arduino exercise playlist, exercises 5 and 6, and do a preliminary flow chart of your up function. And then I'll give you more information on Thursday that will allow you guys to go off as a team and to begin to do some coding. Before we go, Tyler says my flow is crazy. Well, send it to me, Tyler. I'd be interested in seeing it. The other thing I'll say is that the the other library that you're going to need access to is the servo library, because you'll use uh, that library to drive uh, your system via the PWM levels. Okay, so I believe you'll need to have a hashtag include with identifying the servo library up top in your code so that you'll be able to do the functions that are necessary. And again, I'll try to get some more information on that on Thursday. Okay, so everybody's good. Give me an agree. All right. All right, you guys have a good week. Email me if you have questions, and we'll talk some more on Thursday relative to variable names, and I'll give you some additional information with respect to the output necessary to drive the elevator system. All right, you guys have a good week.